Okay, we're going to focus on probability, and we'll actually even do our own experimental probability. I'll get you to Christina going to die in a second. Now, this is what probability is equal to. So probability of something is equal to, now this might sound odd, number of times the event can happen, okay, divided by the number of possible outcomes. Okay, those are long definitions, right? But maybe it'll help start to make a little more sense. Let's talk about rolling a die, okay? So on a die is a cube, right? A piece of dice. How many sides are to a die?
No. 6.
6, that's right. There are 6 sides. So we have 6 sides to a die. And what are all the numbers on a die?
1 to 6.
1 to 6, and there's one side for every number, right? So essentially your options are 1, 2, 3, 4, 5, 6. So if I roll a die, how many outcomes can I get?
6
I have 6 possible
outcomes.
And that's called theoretic. In theory, there are 6 possible outcomes, okay? And in reality, there are 6 too. So that would kind of fulfill the bottom part of our fraction, okay? We have 6 sides. The first one says P of 6. In other words, what's the probability, that's what P stands for, of getting a 6? Well, how many different times can this event happen? Well, when I roll one die, how many different ways can I get 6?
1.
Just one. I can only roll it to get it one side. So the probability, how many outcomes are there?
1 out of 6.
Is 1 out of 6. There's only one way I can get that, right? There are 6 possible outcomes, and there's only one way I could get a 6. Okay, P of an even number. Well, what are the number of possible outcomes?
3 out of 6.
There's 6. That's right. And even numbers, well, we have 2, 4, and 6. There are 3. So that's 3 out of 6. What about less than 3? Well, what's the total number of outcomes?
2. Out of 6, sorry.
6. And then less than 3, well, that's the numbers 1
2.
and 2. So how many out of, would that be?
6.
2 out of 6 would be your probability. Now, this is considered our theory, or they call it theo. Let's make sure you spell that properly. Theoretical probability. But let's say we actually conduct an experiment, okay? So that's theoretical. Okay. Compare. Let's spell this one like too. Mental, okay, experimental probability. I'm just going to put prob, okay? Well, let's actually try these. Let's take A and see what happens. Well, I think I have die. Interactive media. There we go.
So cool.
Okay, so we have a die. Okay, and I'm pretty sure I can roll it by hitting it. So we roll it once, and what did we get?
4.
A 4. Okay, so that's one try. Remember, we're trying to get a 6. So let's write down what our numbers were. In try number 1, we got a 4. And it says we should get it 1 out of 6 times. So we're going to try rolling 6 times. So the first time we rolled, and I'm going to write these numbers for underneath. So that's the first time, second time, third, 4, 5, and 6. So we're going to test this out. That was the first one. Rolled it a second time.
6.
Hey, we got 6 on the second one. So already, technically, how many times have I rolled a die right now?
Twice.
And I got 6 what?
1.
1 out of those 2 times.
Yes.
Now let's see what's going to happen. Roll it again.
3.
Okay. Oh, I can't do that. Roll it again.
6.
6 again. Ah. Roll it again. 2. And we roll it again. And 4. Oh. Now, in our experimental, how many times did we get 6?
Twice.
Or, yeah, we got 6 2 out of the 6 times, right? But that's okay, because what really happens in stats is the more we do something experimentally, the closer it'll get. Now, that's not technically equal to 1 over 6, right? The experiment wasn't the same as the theory, but it doesn't mean the theory's wrong.
Yeah.
Okay? Because look, we actually also got 2 4s. Theoretically, I should have got, what's the probability of rolling a 5?
1.
1 out of 6 too, right? It doesn't change. How many times did I roll a 5 when I rolled it 6 times?
0.
0. It doesn't mean that's wrong. It's just our experiment needs to go many, many times to be very close to the theory. Okay? So that's the idea of there. And let's talk about, okay, well, how many times do we get even numbers? That was the B one, right? Probability of an even. Well, let's take that data we had before. How many of these are even? We have 1, or 4, 6, 6, 2, 4. How many times do we get even numbers?
5.
5 out of the 6 rolls were even, right? Not the same as the theoretical probability, but it doesn't mean it's wrong. Our experimental just gave us a different number. But if we continue to get this, most likely eventually we'd start to get many more odd numbers and it would come closer and closer to that probability. And finally, less than 2. Let's take a look, see what's,
0.
and I'm going to say less than 2. I'm going to write it with a less than sign. Have you seen that before?
That one got confused.
Okay. Anyways, how many times did we go less than 3 was the number. How many times did we go less than 3?
Once.
We only did it once. But what was the theoretical probability?
2.
It was 2, okay? So our experimental and theoretical probabilities won't always be the same, okay? But that's how you calculate probability. You look at the number of outcomes and the many different times you can reach that, and then you can test your experiment if you want and see if you actually get those numbers.